All right, my friends, welcome. We've got another SHSAT here. We have the 2025 Test B, right? So this is the one, the Test A is the one that you may have had a hard copy for. They get sent to the schools like June. And then the B test is just posted online. So same opening script here. This is not a computations test. You can skip this part if you've seen it before, or heard it before. It's not a computations test. It's a test about test-taking strategies, right? So if you're doing some brutal computation, you can be assured that you missed something, right? The purpose of the question, right? You still may get the right answer, but, you're wasting time. The people that know the strategies are not going to be wasting time. And with that, I think we can probably get started. So for the first one, pretty simple, right? They just want to know the coefficient as a decimal. So I don't even really need to distribute to the constant, right? We can. So 3/5 of 2x is going to be 6/5 x. With 3/5 of 5 is 3. Again, not important, but we'll put it in there. And then we've got the like term, negative 2x. So we've got 6/5 and negative 2 that we're combining. So we can convert them to decimals now if we want, right? So if this is 1 2/10, and this is negative 2. When we subtract, we should get negative 8/10 x. So the coefficient of x is going to be negative 8/10, right? That was pretty straightforward. All right, 59. So this is one where it's good to be familiar with the sample space of two dice, right? So if we have our two dice here, let's throw another one on here, right? We should have seen these before. Right, so you don't want to be making this every time like I am here, right? So I always like to think about, and if you're familiar with this, you can skip on past this first part. All right, but I'm going to show you the sample space again. This is something that you should be familiar with prior, right? If you're thinking about the amount of time it's taking me to set this up for you. So it says we're talking about a sum. Now, some questions may ask about a product. That's a little bit trickier. But once you've done this, you probably will be able to memorize the pattern, right? So here are my sums. And so obviously we can fill this in vertically or horizontally. And it's pretty mindless because we can tell exactly what the pattern is. All right, so these are my sums. So we go all the way from snake eyes, right, a pair of 1s, which is the sum of 2, to a pair of 6s, which is 12. So there's 6 by 6 or 36 different outcomes. Now, if we wanted to, and again, this is certainly not something I would do, for the sake of this question, but just so you guys can see what happens is these are my different sums. Right, I can have 2, 3, 4, 5, 6, 7, 8, 9, 10, and I'll move it down here. 11, 12. Now, how many ways can I roll a 2? Well, only one way. How many ways can I roll 12? Only one way. How many ways can I roll in a 3? 2 ways. I'm sure you can figure out that there's 2 ways to make an 11. How many ways are there to do a 4? And then 4, and then 5, and then 6, and then 5, and then 4, and then 3. So we have this nice sort of symmetry here. So again, if you've done problems like this before and you've looked at the sample space, you can probably memorize, as I obviously have here, what that's going to look like. Now, alternatively, let's say you don't want to go that route. You can say, hey, I want a sum of 6. Now, you do need to understand that the two dice are different. So that's why I always make it like a red dice and a blue dice, right? Because we're like, well, a 4 and a 2 and a 2 and a 4, those are different outcomes, right? Again, consider that the dice are different colors. So if I'm using my sample space here, I'm just going to look for these. And I can clearly count up 5 6s. Now, if I'm not going to do that, I'm going to say, well, I can have a 1 and a 5, a 2 and a 4, a pair of 3s, a 4 and a 2 and a 5 and a 1. So I don't necessarily need to go through all the trouble there of listing out the sample space and then listing out that big list on top. But again, for problems like this, right, it's good to go into the test being aware of both of these things, as in like this and this. And that will definitely kind of set you up for success because then you don't really need to list all this stuff out every time. All right, we do have a good shortcut for number 60, right? So it's a scale drawing question and it's perimeter. Now, just understand that anytime you have questions like this where you have these right figures, these figures with right angles, right? All I need to find the perimeter, so I'm going to say, like, let's say those are my dimensions. And if I ask you what's the perimeter, you can tell me the perimeter is 36. And we're going to say, well, how is the perimeter 36? You don't have those little pieces. I don't need the little pieces, right? In other words, if this is 10, then this and this and this, right? All the vertical segments, if I put them together, are going to be 10. And I'm sure now we can figure out that if this is 8, then this and this and this joined together will be 8. So that's how I got 36, whatever the units are. I'm not trying to neglect my units, but that's what it's going to look like. So really here, I know that this is 13, and I know that this and this is 13. Could I subtract and figure out that this is 5? Sure, but I don't need to. I could just take 13 and double it. Right? Similarly, with the vertical measurement, if this is 6 and this is 3, clearly that's 6 minus 3 or 3, but I didn't need it. In other words, I could have solved this question without those two pieces of information. They were nice and they gave them to us, but they didn't have to. Right? So 13 plus 6 is 19 times 2 means the perimeter is 38 centimeters. Now they're telling us that it's a scale drawing, so 38 centimeters, each centimeter is 2.5 meters. So I need to multiply 38 by 2.5. So I want two groups of 38, which is 76, plus half a group of 38, which is 19, and that should give me 95, right? We're trying to always avoid standard algorithm multiplication or division, and I pretty much think I do a pretty good job of doing that almost all of the time. All right, this is one of these questions where you just got to read it a bunch of times, right? So it says, and so, sometimes they'll have questions like this about, the temperature was at 9 a.m. was this, and for the next 6 hours it did something, but then they'll ask you about the temperature 2 or 3 hours before, right? So we just have to be really careful with reading the question. And it said between 5 and 9 a.m. it went from -7 to 4. And then by 11 it was 3.5 times the temperature at 9. All right, so we need to know 3.5 times the temperature when it was 4 degrees. So similar to what we did before, I want 3 groups of 4, which is 12, plus half of 4, which is 2. So the temperature was 14. What was the total increase between 5 a.m., when it was -7, all the way up to when it was 14 degrees, and we should be able to subtract those two. 14 minus -7 should give us positive 21. All right, 62. This is one that's going to kill some people because we don't really do too much of this in school, right? We do a little of this maybe in 6th grade, but this is one that if you're not really prepared for this test, you're going to struggle. Now, we want to remember that volume, right? So I ask my class, what's volume? And they say length times width times height. And they say, no, that's the volume for one particular figure. The volume of a regular solid here is B times H, where B is the area of the base. Now that base could be anything. It could be a hexagon. It could be a trapezoid, right? If we have parallel bases. So the reason that this is the formula, and it's hard because I'm using my hands and you can't see it, but it's the amount of stuff, right, that we can fit on the bottom layer times how high we can stack those things, right? So if we think about a big box and we have a bunch of cubes we're going to fit in that box, it's the number of cubes we can fit on the bottom, that's the area of the base, times the height. Now, the base here is this triangle. So if we think about what's underneath, right, what this is sitting on the floor, and I can't draw it because I don't see the triangle that's there, but know that there's a triangle like the one I highlighted in blue on the bottom, or you can take the one we're looking at now and just turn it upside down. So that's how much stuff we can fit on the bottom, and then times the height. Now, how am I going to find the dimension, the area? Well, that shouldn't be so hard, right? So if that's 4, this is 4, and the vertical measurement is 2. So that looks like a square, the way they drew it, but it's a rectangle. Right? So it doesn't look like the length is double the height, but it is. So I need to take the area of this, right? So that's going to be 1/2 times the base of 4 times the height. Right? So that's this. That's the B. The area of the base is 16. So that's how many cubes I could fit on the bottom. Obviously, they'd be kind of scrunched and cut because it's a triangle, but that doesn't matter. And it's going to be times the height, right? Which is 2. So 16 times 2 is going to give us 32, and it's volume, but we don't really need to label units in this test, right? Especially this question because, well, they're saying cubic inches. It's going to be 32. So that's one we want to make sure. And again, they're not going to give you, like I said before, a hexagon or something. That's too hard for us at this level to find the area of. But rectangle, square, triangle, make sure we find the area of that, and then multiply it by the height, and that'll give us the volume. All right, so this test kind of runs the gamut of a little bit of that 7th grade stuff that I've talked about in some of these videos. Right after COVID, they decided that they were going to put on, whereas they used to have like nothing you do in regular school, they put in about, I don't know, maybe 20%, maybe less, of some 7th grade standards. So we've got a unit rate question, right? So you're just interpreting it, right? 1, right, that's the x, that's the length, and 4, that's our ounces. So 1 foot is 4 ounces. So 1 foot per foot is 4 ounces. So that's pretty straightforward. This one also, right, we're going to go through some of these kind of quick. We should know that that's going to be -2, which is going to be F. So this is one where you just need to have a strategy, right? We're on the surface, we're going to say, wait, how can I solve for X and Y when there's it's one equation, right? We don't have a system. So we're going to cross multiply. And when we cross multiply, we get 2x times 3y is 6xy. And we get 9 times 8 is 72. And we divide by 6, and we get exactly what we want, right? xy is equal to 12, so the product of x and y is 12. So that was pretty simple. All right. Consumer math. So we see some of this. I will warn you, some of the ones on some of the practice tests are like ridiculously kind of brutal as far as the computations, things that we wouldn't normally see. So at some point when I do, those videos, I'll be sure to let you know that, hey, like my rule about if you're doing a terrible computation doesn't really apply here because this wouldn't be on the actual test. But this one's pretty reasonable. So there's a 12% discount. So we're going to say, well, okay, well, let me take a 10% discount, right? So 10% is going to be 1/10. So we just take off a 0. So 1560. All right, so if I take $1,560 out of this, I'm looking at about $14,000. But I need to take off a little bit more because I only took away 10%. Well, choice H is throwaway, right? Now, alternative strategy here is using the ones digits, right? So a 12% discount, right? So we've talked about this before, right? If I'm supposed to pay 100% and I'm getting a 12% discount, then that means I'm paying 88%. That means when I go to do this computation, if I was to do it sort of by the book, I would be doing this. Now, what can I do here? Well, I can multiply this by 100 and divide this by 100. So really, my exact answer is going to be this. Now, I told you, I'm not doing any standard algorithm multiplication, but I do know that if I want the ones digit of the product, I multiply the ones digits of my numbers, my factors. So 6 times 8 is 48. So my answer is going to end in 8. Well, that's the key because that gets rid of F and G. Choice H is if we took off $12, that's a complete throwaway choice. So E is going to be our answer using our ones-digit strategy. Using approximations, again, if I take 10% off, that's going to get rid of F, G, and H also, and I can safely pick choice E, but I would always check ones-digit strategy as well. 67 is just a computation, so let's turn this into an improper. Let's turn this into an improper. Let's multiply by the reciprocal, right? So these are the questions that I don't really, as far as strategies, it's just kind of just do it, right? And there's not too many of those, but sometimes you just have to do the computation. So this one's pretty easy. So there's 36 players, and there's 3 coaches, and the ratio of assistants to players is 1:6, right? So assistants to players is 1:6, but there's 36 players. So it doesn't take too much math here to figure out that if I multiply by 6, that means there's 6 assistants, right? Now it says what's the ratio of coaches to assistants? Well, that's going to be 3:6, which simplifies, of course, to half, right? So far, so good. All right, so this one is really just a dressed-up subtraction question, right? So it says each post is 10 feet long, right? So this is the grounds. And we need to put the post down here, right? 3 1/3 feet underground. Right? And that's the post, right? So the post itself is 10 feet. So how far is it going to be above the ground? Well, it's 10 minus 3 1/3. Right? So if I do 10 minus 3, that's 7. Subtracting another third is going to be 6 2/3. Right? Not too much to do there. Number 70, I'm going to substitute R for... So there's 2 ways to do this one. You can distribute, move your terms, and then substitute. I'm going to substitute first. So if R is 2, 2R is 4. So that's P plus 4 is equal to R, which is 2 times the quantity P plus 1 plus 1. So I get p plus 4 is equal to 2p plus 2 plus 1. So if I wrote 3 because I'm just combining the like terms a little prematurely there. So if I add negative p and I add negative 3, we get p is equal to 1, right, which is going to be choice F. 71, and it says Karen reads 60 pages a day, and Martina reads 25% more. All right, so 25% is 1/4. Right, so 1/4 of that is going to be 15 plus the 60 is 75. If you want it to be really savvy, you can say that Martina reads 125% of Karen's, which is 5/4, and multiply by 5/4, right? 1.25. There's a lot of ways we can do it. Now, it says they both read 1,500 page books. So we're going to say, all right, let's do the easy part first. 1,500 divided by 75 is going to give me 150 divided 75 is 2, times 10 is 20. And at that point, you can use ratios. So I'm going to do this the traditional way and do the division, right? And they want the difference in the number of days. So Martina's going to take 20 days, Karen's going to take 25, so it's a 5-day difference. You can also think about that because of the rates, they're going to be proportional, right? So the ratio 60 to 75, right, is equal to 4 to 5, right? So that's the ratio of their speeds. So really, if you knew one of their speeds, you can either multiply it by 4/5 or 5/4. So here, right, Martina's the faster reader. It's going to take her 20. That means it's going to take the other person the reciprocal of that, which is going to be 25. Now, you don't necessarily need to do that, obviously, right? The division parts we did were not especially terrible, but when we talk about comparing speeds, it's sometimes important to use the ratios of their speeds, and the ratio of their times will be the reciprocal of that. All right, the next one is just kind of a remainders question. It's kind of dopey. There's not really too much to say here, honestly. So she already ran 650, and she's doing 120 laps, and she wants to run at least, right? So I don't really need the symbol there. So if I subtract, I'm going to get, 1850? All right, so now we're dividing here. So I know that 180 divided by 12, right? So 18 is 1.5 groups of 12, which means that 180 will be 1.5 times 10, or 15 groups of 12. So 185 means we're going to have to run another 5/12 of a lap, which we're not. I mean, we could do, but how many full laps, right? How many more laps? So she's got to do. That's why G and H were so close. Because if you divide and round down, you're going to get 15. But when she does 15, she hasn't run the whole 2,500 meters. She's a few meters short. So we need to do that 16th, even though it's going to put her over. All right, so we see a few questions like this here. So it says it grew 25% and then another 10%. Now you can't add the percents together, right? It doesn't work like that. So one thing we can do is just do 200 times 25%, add it on, and then take 10% of that and add it on. And that's fine. Right? There's nothing wrong with doing it that way. It took me a little bit of time. If you want to be more savvy about it, we're going to say, well, you always think about what you retain. So in other words, if I grow by 25%, I'm going to end up with 125% of what I had before, and that's 5/4. So I'm multiplying this by 5/4. And now I'm going to add 10%. So I'm going to end up with 110% of what I had after that first increase, and that is a simplified fraction is 11/10. Well, this is going to make the math a lot quicker, because certainly I can divide out the 10, I can divide out the 4, and now I've got 25 times 11, which is 275. So it's generally easier, but you also have to be pretty fluent with, converting percents and fractions, which shouldn't be that difficult, honestly. All right, and that's what it would look like. All right, we see a bunch of probability in this test, which is good because we got to prepare for it because we don't always do enough of that in our homeschool, and we see lots of these questions on the test nowadays, a lot of probability. So the probability of green is twice as great as probability of red. Well, what does that mean? It means there's twice as many green as red. So if there's 12 green, there would have to be half as many red. That way the probability of picking those green would be twice as many of the red. So it says, what's the probability of choosing yellow? Well, we need to add these up. That's going to give me 22 total, and 4 of them are yellow. Divide by 2, and we get 2 11ths. Someone at the state of New York is in love with box and whisker plots. I don't know when this started or why, but between the Regents, the 7th grade state exam, the SHSAT, even the SAT, I guess, and that's not even a New York State thing. I don't know why we see. There was one year, they think kids said that they had 3 questions on interquartile range on box and whiskers. I'm not really sure why, because in real life, they're kind of useless, but I digress. Let's see if we can figure out which of these is correct. An outlier. So an outlier is a point that really doesn't fit, right? So if this is my box plot, and I had a point like that, right? Okay, that's an outlier, right? That really skews my data. I don't have that here. All right, so I don't see an outlier. The mean of the data is 16. Well, let's do a little refresher here on box and whisker plots. So we've got the median in the middle, right? Sometimes we call that the second quartile. And down here we have what's called the first quartile, we have the second quartile, we have the minimum and the maximum. So we don't have too many actual data points. I have the minimum and the maximum. I don't even have the median. I don't know if there's a 16. I don't know if the 2 middle values were not 14 and 18 and they averaged out to 16. So a box plot doesn't really give you much hard data. It gives you the spread, right? Because each of these pieces represents 25% of the data. That's not especially useful. It just shows how spread out and skewed it is. So A is out. We have no clue what the mean is. I don't have any values. The interquartile range, and again, I don't know who's in love with this metric, but the interquartile range is this minus this. It's the size of the box. So the interquartile range would be 24 subtract 12, which is 12. Okay, so that's wrong. On 25% of the days, there was between 12 and 16. Well, if each of these pieces represents 25%, well, then that would be right? 25% would be between 2 and 12, 25% here, 25% here, 25% there. So that's the only one that we can actually deduce as being true based on this. All right, so questions that ask you for an equation, I would say 99% of the time it's going to be a proportional relationship, right? It's not going to be y equals 2/3 x minus 5, though it could. So if I think about using my rule for a proportional relationship, dividing y by x, I get 2/3, I get 8/12, which is 2/3, I get 12/18, which is 2/3. Okay, so that was easy. Alternatively, just choose some values, right? What happens if x is 18 and y is 12? Well, 18 minus 1 does not give me 12, and 18 plus 6 does not give me 12, and 3/2 of 18 is 27, not 12. 2/3 of 18 is 12. Okay, so even if you had no concept of this, another thing the state's in love with, right? Proportional relationships, just use the choices and substitute them in. So this one was a little tricky. The first time I didn't read the whole thing because there was too much text and I was being lazy. And then I said, I worked this out a whole bunch of different ways. And then this part, right? So it says there's 200 residents, right? They sampled. So a sample is going to be representative proportion. And it says half of the undecided voters will vote in favor. Okay, so of these undecided voters, we're going to put 10 of them here, and we're going to put 10 of them here. Now it says how many of the 24,100 will be in favor? Well, 152 out of the 200 that we surveyed are going to be in favor. All right, so one thing we can do is we can think about using an approximation. Right, 152 out of 200 is almost exactly 3/4. It's a little bit bigger than 3/4. So 1/4 of 24,000 is 6,000. So 3/4 would be 18,000. So it's a little bit bigger than 18,000. All right, so C would be out. C and D may be too big, but we'll see. So remember what we've talked about before. When you simplify a proportion, you can simplify vertically or horizontally. So now I divided out 100. I'm going to divide out this 2. So I get x times 1 is equal to 76 times 241. So back to my ones-digit strategy. It's coming in handy for a second time. 6 times 1 is 6. This number will end in 6. All right. We saved ourselves a lot of heartache multiplying these two numbers. And if you did it, that's fine. You're going to get the right answer. But again, we want to think smarter, not harder. Just using the approximation, right? If I approximate this as about 3/4, like I said, 3/4 of 24,000 is going to be 18,000. But I lowballed on both of these, right? I did 152 down to 150 and 24,100 down to 24. So it should be a little bit bigger. Not a crazy amount bigger, a little bit bigger. So it checks the approximation box, but the one-digit box is the even better one. All right, which of these is going to be the greatest, right? So we're talking about negative numbers, right? So if we've got 0 here and we've got -1 here, we want the one of these has the smallest absolute value. All right, so clearly -49 is out, -1 is out. Now, if this is -1/7, -1 out of 49 is going to be very close to 0. That's definitely going to be the greatest, right? Again, we want the one that's furthest to the right on the number line. All right, 79. So I don't know that you're going to see something with 11ths on here. So I always say it's good to know your thirds, fourths, fifths, sixths, eighths, ninths. If you're a nerd like me and you know sevenths, I have a t-shirt with the sevenths. They repeat every 6 places. That's not something they're going to expect you to memorize. 11ths is a little obscure also. So let's say you were doing this by the book, right? We're going to divide the denominator into the numerator. No, I don't really want to do this. I guess I'll do it after. Now, if you've worked with 11ths before, 11ths are repeating decimals that repeat every 2 places. And like all repeating decimals, if you know one, you can find another one by multiplying. So if that's 0.09 repeating, doubling that is going to double the 09. It's going to be 0.18 repeating. And if I triple it, it's going to be 0.27 repeating, and so on. All right, so if you knew that already, then you know this is going to be 1 and 2 11ths, which is going to be 1 and 18 repeating. We don't care about the negative necessarily, so it should be C. Now, if you did want to grind it out, which we can do if we really wanted to, right? What's going to happen? I'm going to get 1, 8, 1, 8, 1. So it's going to repeat. So it's going to work, right? If you want to do standard algorithm. Again, I don't know how common it is. You know, if they ask you something like 3/8, yeah, you should know that 1/8, right, is 125 thousandths. So 3/8, I just triple it, right? Right? If we know 1/9 is 0.1 repeating, then we know 2/9 is 0.2 repeating, 7/9 is 0.7 repeating. So some of these are good to know. You know, something like 13ths is a really, really terrible one. 17ths, some of them get pretty bad. 12ths is not great, but things like thirds and sixths, certainly fifths, fourths, those we should know. Number 80 is very simple, right? If 1/5 of an ounce of salt per loaf, really we're doing 40 divided by 1/5, so we're multiplying 40 by 5, so we should get 200 pretty easily there. 81, in my numerator, I have -1/7. In my denominator, I have -2/7. So when we're dividing fractions, if the denominators are the same, we can eliminate the denominators. And really what I'm left with is -1 out of -2, which is going to be half. Now, you don't believe me and you want to say, hey, wait, I was always taught to multiply by the reciprocal. Sure, right? We can do that, and we'll see that exactly what I said is going to happen, right? Those 7s will divide out. Again, we're thinking about the fact that we've got these fractions of the same size pieces. So my numerator, I've got 1 piece of a certain size. My denominator is 2 pieces of the same size. Well, if the size is the same, I don't need the denominators anymore. I just need to know the number of pieces since they're the same size, right? So it's going to be half. All right, 82. Compound inequality. We do sometimes see these, and this is something, we don't even do this in Algebra 1 anymore, believe it or not. So this is one that really throws kids through a loop. Now, the right way to do this is to split it up into 2 inequalities and bring it back together. But really, we can solve it all at once, and that's the way we generally do it. So I'm going to add -1 to the left inequality and the right inequality, which gives me -7 less than or equal to -3x less than or equal to 3. Now this is where it gets a little wacky. So I'm dividing by a negative. So I'm going to do the math first. And then since we divided or multiplied by a negative, I need to switch the symbols. So that was a pretty tough one. And we got to graph it now. So I've got 2 is bigger than x, so x is less than 2, but x is also bigger than -1. Let's check this and make sure it works. So if we look at choices E and F, they're almost the same, except for the solid or, shaded. Let's see if 0 works, right? So if I substitute 0, I get -5 is less than 1, which is less than 4. Okay, so 0 works. So G and H don't include 0, which they should. Now, obviously, just by the fact that these have or equal signs means I should have 2 shaded circles. So there's a lot of things that we could do in advance, right? I could have eliminated, if I just checked for the shaded circles, all right, this doesn't have them. This has 1 shaded circle, so that's really even the easiest way to do it, right? I wanted to show you the right way to do it, but really if you just use the shading, you could have no knowledge of inequalities other than solid, shaded and unshaded, and you can eliminate all the bad choices. All right, so I'm going to do 83 by the book, and then we'll talk about some other ways. So 1 sind is equal to, I like fractions better than decimals. All right, so really what I have here is 3/4 x is equal to 8. We know that we're going to multiply by the reciprocal, which is 4/3. I get x equals 32/3, which is 10 2/3. All right, we can use some approximations too. Like, I may want to just clear the fraction at the beginning. So if I multiply this thing by 4, it tells me that 4 sinds is equal to 4 times 3/4, which is 3 plunks, which means that 8 sinds will be equal to 6 plunks. Well, now all the bad answer choices are out. 6 plunks is already equal to 8 sinds, so 8 plunks is going to be more. So these are all gone. So we always have a variety of choices, right? If you're doing some sort of grinding, number bash, right, think about saying, well, can I eliminate all the bad choices just based on scale, right, just based on reasonableness? This should be a pretty easy one, right? Distribute that negative. 8x minus 7 minus 2.5x plus 2. So I'm going to get 5.5x minus 5. Not much to say there, right? Choice F. All right, so we have these two 30-member exercise groups. Okay, that's important. Both groups have at least one member who is exactly 29 years old. Well, this one does, right? The oldest person in group Q is 29. I don't know anything about this. I cannot say that that's true. Group P has more members who are at least 17. Well, let's see. Group P, right, has all of their members to be at least 17 because their younger one is 17 than Q. Okay, that seems like it should make sense, right? Let's look at choice C. Both groups have an equal number of members between 21 and 24. Well, 21 and 24 isn't an actual, it's not a box, and it's not a box here either. That doesn't make any sense. Group Q has fewer members who are between 19 and 27. All right, so let me take some of this down. All right, Q between 19 and 27. So I don't know, again, that's not a box either. That's like a middle of a range, right? So this one makes sense because everyone in P, right? The youngest person in P is 17, so everyone is at least 17, whereas the other one has 75% because that first 25% is not in the range. All right, 86, this one's pretty straightforward. It says the probability of yellow from jar Q is 1/3. Okay, so that means that Q has 12, then 1/3 of 12 is 4. And it says the probability of drawing yellow from R is 3/4, right? So R has 8. So 3/4 of 8 is 6 yellow. And it says we mix them together. Great. So there's 10 yellow out of 20. That's half. Nice and easy. All right, 87, very simple ratio question. So pretzels to raisins is 12:9. Divide that by 3. My ratio is 4:3. Obviously, this one makes no sense. It's 1:2. This one is going to be 5:4. That's wrong. This one's going to be 6:5. And choice D, if I divide by 4, I sure enough get 4:3. Nice and easy. 88. So we're going to do some substitution here. I'm going to do it first. So I've got 3y here, and I've got, actually, I take that back. I'll distribute first. So I get 3y plus 6y plus 10 minus x. So that's going to give me 9y plus 10 minus x. So it says y is equal to 4x. Well, we can probably tell then that 9y will be 36x. plus 10 minus x, so 35x minus plus 10. Right? That one's pretty easy. All right, so we talked about this before. Make sure you know area and circumference of a circle. They are not given to you. They expect you know them, even though we don't really see this too much in regular school anymore, unfortunately. So they're giving us the diameter. So if the 18 is the diameter, the radius is 9. If 12 is the diameter, the radius is 6. So it's pi times 9 squared minus pi times 6 squared. So if you want to be savvy, like one of the other videos, we can use difference of two squares, right? So a squared minus b squared is the sum times the difference. So if we want to use that, we would say that this would be 9 squared minus 6 squared is going to be 9 plus 6 times 9 minus 6, which is going to be 15 times 3, which is going to be 45 pi. If that's too much, then you just do this, which is going to give you 81 pi, and you do this, which is going to give you 36 pi, and sure enough, subtracting them will give you our 45 pi. All right, a lot of kids had trouble with this one when I did this in one of my classes, right? So the sum of x, right, x is negative 4, plus 10% of the absolute value of x. So the absolute value of x is 4. 10% of 4 is 4/10. So negative 4 plus 4/10 is negative 3 6/10. All right, we see a few of these from here to there. The volume of a cube is 512. Okay, so I've got a cube, right? Not that I need to draw my terrible cube. So the volume of a cube is side cubed. So I need to know what measurement, when I measure the length times the width times the height, is going to give me 512. So I mean, the choices are just ridiculous, right? Even if you don't know. I mean, really what you could do is you could say, well, if you know something about powers, you could say, well, 512 is actually 2 to the 9th power. And 2 to the 9th power, if I take the cube root, is going to be 2 to the 3rd times 2 to the 3rd times 2 to the 3rd, which makes it 8 times 8 times 8. Now, I don't necessarily need to know that, but we need to know that choices B, C, and D are ridiculously large, and choice A is going to be the one that 8 cubed is 512. All right, 92. This one's a little tricky. So on Monday, right, we're going to lay out all that information was X. On Tuesday, it was 84. And that was a 5% increase. So the way we want to think about it is if it's a 5% increase, that's 100 plus 5%, 105% of X. Meaning 84 out of X is 105 out of 100. Or as an equation, you can say 84 equals 105% of X. Now, the good thing about the proportion is if you simplify this by dividing by 5, we realize that now we've got a smooth multiplier here of 4. So if I multiply by 4, it's going to give me X is 80. And we might have been able to reason that out on our own, right? That a 5% increase, it wouldn't work with like 82 or 81 or something, but if you take 80, knowing that 10% of 80 is 8, that would make 5% of 84, and that represents the increase. Okay, so that's Monday. Now we got X. Now on Wednesday, it was 10% lower than Monday. Well, we should know that 10% of 80 is 8. So Wednesday is going to be 72. And now it says how much lower was Wednesday than Monday, right? So 72 versus 80 is going to be a difference of 8 degrees, which is going to be F. 93, this is a tricky one. So it says, what's the greatest possible value? So we've got 3 consecutive integers that are factors of this number, right? So if n is 3, 2, 3, and 4 work, right? Because this number is divisible by 4, which makes it divisible by 2. And the sum of the digits is 15, so it's divisible by 3. I think it's 3 times 56. It says, what's the greatest? All right, so maybe that's going to work. And we're going to say, well, let's see if anything else will work. Well, is it divisible by 7? Well, yeah, it's divisible by 7, right? If 140 is divisible by 7, and 168 is 28 more, then it's 4 more than that. So it's going to be 24 times 7. So I'm going to say, well, what if n is 7? Is this number divisible by 6? Well, yeah, we already saw that it's divisible by 2 and 3, which makes it divisible by 6. Is it divisible by 8? Well, yeah, 160 is 8 times 20, so this is 8 times 21. So the greatest number that's going to work is 7. And then we say, wait, but what about 14? Does 14 work? It's divisible by 14. It is divisible by 14, but it's certainly not divisible by 13, and it's not divisible by 15 either. So the biggest one is going to be 7. All right, so these date questions are always easier than they seem, right? I like to think about time on a number line. So it says his second performance was 86 days after his first one. Okay, so this is the second one, this is the first one, and it says the second one was on a Tuesday. So I need to go back 86 days. So I'm going to say, well, what's 86 divided by 7? And I'm going to say it's 12 remainder 2. That means I need to go back 12 weeks, which any multiple of 7 is going to get me the same day, but I have to go back 2 more days. So let me go back 2 more days. So I go back 12 weeks, now it's a Tuesday, right? 12 weeks ago. And then the day before that's Monday, and the day before that's going to be Sunday. So choice E, right? There wasn't a whole lot for us to do there. All right, 95. He had 213, and it says his total pay after 32 was deducted. What was his pay before that? All right, so 213 plus 32 is 245 divided by 20. So 200 divided by 20 is 10. 240 divided by 20 is 12. There's an extra 5/20ths, which is 1/4. 1/4 of $1 is 25 cents, so $12.25, right? Pretty straightforward. All right, surface area. So one thing we can do is we can know the formula, right? So surface area of a rectangular prism, right? Not any shape, right? Surface area of the shape is the sum of the areas of the faces. Sometimes we have a box that's open on top, so then we can't really use the formula because the formula is counting all of them. So it's 2 times pick 2 lengths, 2 measurements, pick 2 other measurements, and then pick 2 other measurements. So I don't memorize this in any specific order. I guess I probably just defer to this one. But you're going to pair up the length, the width, and the length and the height, and the width and the height. Now, let's say you don't want to use the formula. All right, you're going to say, well, this is 20 by 40, and so is the one in the back. So 20 times 40 times 2, right, is going to give me 1,600. And you're going to say, well, I'm also going to have this one, which is 20 by 50, and there's going to be one in the back. So 20 by 50 times 2 is going to give me 2,000. And I'm also going to have the top and the bottom, right? And the top and the bottom is going to be 40 by 50 times 2, which is going to give me 4,000. And if I add these together, I get my 7,600, right? So I could have just also plugged these into the formula, right? So one of them doesn't really matter. Let's make L 50, right? Let's make the W 40, and let's make the height 20. And if you sub it in all the places, I don't need to do that for you. I essentially just did it, just not in the same exact way. We're going to get the same value for the surface area. But make sure you know the formula is good to know. Being able to count up the faces is good to know. All right, 97 is like a linear equation where we're modeling decay, except it's linear decay. So it says it's worth $1,500 3 years after we bought it, right? So we had times 0, right? So I bought the car. I don't know what it was worth. 3 years later, it was worth $15,000. And then 5 years after I originally bought it, it's worth $10,000. So what's happening, right? Every 2 years, it's losing $5,000. That means every 1 year, it's losing $2,500. So what happened 3 years prior to this? Well, it must have been worth $2,500 more times 3. Right? So it must have lost $7,500 to get to $15,000. So I'm going to add that here, and it's going to give me $22,500, which is going to be choice C. All right, some of this probability gets a little intense here, right? So this is probability without replacement, right? So without replacement means exactly what it sounds like. We take something out, we don't put it back. So the entire pool of items is going to decrease by 1. The numerator may or may not decrease by 1 depending on what we're going to take out next. So what's the probability of 4 blue discs? Well, right now there's 9 discs and 4 of them are blue. So the probability now is 4/9. So now I took out a blue one. So now it's 3/8. Now I took out a blue one. Now it's 2/7. Now I took out a blue one, so it's going to be 1/6, right? So I'm going to divide out 4 times 2, which divides out an 8, divide out a 3 and a 6, which is going to be 2. So my numerator is going to go to 1. My denominator is going to be 9 times 7, which is 63, times 2, which is 126. And that's going to be answer choice F. So make sure we know probability and without probability. Number 99, I mean, really, we can just play which of these things is not like the other, right? Because it says which is not another way to write this. That means all the numbers are going to be the same, right? So if I simplify choice C, I get 1 out of 200. All right, this looks good because C and D are now the same, so they can't be the answer. Choice B, if I multiply the numerator and denominator by 2, I get 1 out of 200. Oh man, that's great. B, C, and D are all the same. Choice A looks kind of small, right? So if I want to put that out of 200 and I multiply by 2, right, that's going to give me 0.01 out of 200. That's not right. That is way too small, okay? If I want to make that even just have integers for the numerator and denominator, I'd have to multiply by 1,000. Right, so that's what it's going to look like. 5 out of 100,000. That is certainly way too small for what we're looking for. Okay, so we're definitely going to take choice A because B, C, and D, even if we didn't have a reference, right? If I didn't see this, if it said, which of these is different? B, C, and D are the same. A is way smaller. All right, 100 is an exponential growth function. So it says we start with 50 and we increase by 40% 3 times. So really what we're doing is we're doing 50, right? So every year we're going to get 140% of what we started with. And then 140% of that, and then 140% of that. All right, I'm not doing that. That looks terrible. It is terrible. So I'm going to say, what's 5/4? I'm sorry, what's 1 and 4/10, right? It's 7/5. All right, so this seems better. Marginally better, but better. Right? So what can I do here? Well, 5 times 5 is 25, and 50 divided by 25 is 2. 7 times 7 times 7 is 343. So this is going to be 686 divided by 5. Well, the only answer choice that's reasonable is H, right? It's going to be rounded, so I don't even need to do the multiplication, whatever the division, whatever this could be. It's going to be 120 and 16, 136, 137 and a fifth, right, if you need to see it. Right, so sure, H is right, but all the other ones are too small, right? I mean, even if you just did, right, so like it's 50. All right, let me increase by 40%. Well, 40% of that is going to be, 20? So we're going to be up at 70 now. Now I need to take 40% of that, which is going to be 28. And now I take 40% of that, which I'm going to say it's about 40, right? Because 40% of 100 would be 40, so it's going to be a little bit less. So I could do it that way if I want. So we have lots of different strategies, but again, we come back to the same thing, right? Some of these computations that seem kind of grueling, we really just want to get to a place where we can get close enough to eliminate all the bad choices. All right, 101. I don't even like doing questions like this because I'm not really teaching you much here, right? I mean, there is one thing maybe to do here. So the fact that I've got 6x on both sides, I'm just going to get rid of that. So I can do this in a few different ways, right? Obviously, the easiest thing to do would be to add 10 and divide by 5. But if I want my variable on the left, which I don't necessarily need, I definitely don't need it, right? I'm going to do this, and I'll do the other way after. So now what happens? I divided by a negative. So for the second time in this test, we had to divide by a negative, meaning we had to flip the symbol. Now, alternatively, if we wanted to go back and say, wait, why is this guy doing this, right? He's got this pretty simple equation, right? All it says is that negative 20, right, is less than 5x minus 10. Why don't we just add 10 on both sides? I'll bring it up here, right, and divide by 5. And you get negative 2 is less than x. Well, yeah, that's the easier way. That's the way I actually would do it. But then we have to interpret what that means. What does it mean if negative 2 is smaller than x? It means x is bigger than negative 2. All right, which is what we have here anyway. All right, so that's a good way to check, right? To do it one way, move it to one side, divide by the negative, move it to the other side, and then rewrite it. All right, this should be an easy one. We honestly used to see a lot more ratio questions. We haven't seen too many on the last couple tests here. So red to white to blue is 2 to 5 to 3. Now it says that there's 30 total. Okay, well, how many total are there in the ratio? Well, 2 plus 5 plus 3 is 10. Well, obviously that means that I have 3 groups of these things. So 3 groups of 2, 3 groups of 5, 3 groups of 9. So that's how many I actually have. Now it says they get a little tricky with us. 1 paperclip of each color is removed. What's the probability the next one will be blue? Well, so now we're cutting this down. Now, obviously there's an easier way for me to do this. Right? So really I could have just said that, well, if there's 30 paper clips now, when I take one of each of them away, there'll be 27, and there'll be 8 blue. Now I wanted to show you how many of each there'll be. There'll be 5 plus 14 plus 8, which is 27, but we could have been a little bit more savvy with it. This one was a little bit tricky if you're not strong with number theory, right? So it says the smallest number so they give you a clue here. They could have just said, what's the smallest number that's evenly divisible by the first 8 numbers? So they say 60 is divisible by the first 6 numbers, right? Positive numbers. Now we wanted something to be divisible by the first 8. So I'm going to say, well, it's got to be divisible by 60, but also by 7 and by 8. So it's not divisible by 7, right? So I need to multiply by 7. So 420 is going to work for 1 through 7. Now what about 1 through 8? Well, I'm not going to multiply by 8. All right? The reason I'm not going to multiply by 8 is the number's already divisible by 4. So I only need it to be divisible by 2 one more time. Right? So 840 then should work, right? It's divisible by 1 through 6 already. We made it divisible by 7. And since it was already divisible by 4, multiplying it by 2 will make it now divisible by 8, so it should be choice B. Number 104 is very simple. We have 3 things in 3 colors. How many different ways can we do that? Well, I'm going to set up basic slots. I'm going to paint the frame first. How many choices do I have? 3. Great, I painted the frame. Now I'm going to paint the door. Well, you can't paint it the same color as the frame, so I've got 2 choices. Now I'm going to paint the wall. Well, I can't paint it either of the 2 choices I already did, so I only have 1 choice, right? So it's going to be 6. 105, we have a lot of different strategies. So they're similar triangles. So this is going to be my scale factor, 10 to 6. So one thing we can do is we can say if that's the ratio of the sides, then the ratio of the perimeters will be the same. So 9 plus 9 plus 6 is 24. Well, multiply by 4, that should give me 40. All right, that's easy enough. Now, another thing we can do is we can say, well, what's the relationship from 6 to 9 times 1.5? Well, then the relationship from 10 to each of these sides should be times 1.5, and 10 times 1.5 is going to give us 15, and 15, 15, and 20 will give us 40. So we have a lot of different ways that we can do questions like this. You could have also said, hey, this is a 6 to 10 ratio. 6 to 10 is 1 2/3. Therefore, the perimeter will be 1 2/3 times my original perimeter, which is 24. So one group of 24 plus 2/3 of 24 is 24 plus 16, which of course is 40. All right, 106. So this should be an easy one, but I know for a lot of kids it's not. So we've got all these variables in different powers and an absolute value. Now, let's think about what we know. X squared is always, and it says that they're integers, none of which are 0. Okay, so they're positive or negative integers. Now, x squared, right? Whether x is positive or negative makes no difference because x squared is positive. Whether w is positive or negative makes no difference because w will be positive. So I really just care about the things with odd powers. So I want this to be positive. So y and z have to have different what we call parity. Parity refers to being odd and even, or positive and negative in this case, right? So we're going to say, well, if y and z are both positive, then it will work. And if y and z are both negative, then this will work, right? Because if y is negative and z is negative, a negative number to an odd power will be negative. That will make the whole thing positive. And same thing if they're positive. X and w are not going to affect this thing in any way. So let me see which answer choice has G. Y is negative and Z is negative. Right? Choice E and F both say things about X and W. That has no effect on anything. Same thing with choice H. All right, so we're picking a shirt and not putting it back. So again, probability without replacements. So we want, this one is kind of odd because it says the first one we want to be black and then the second one we want to be red. So that's, the numerator usually is going to decrease the same way, but it doesn't necessarily do that here. So I've got 6 shirts and 3 of them are black. So the probability the first one is black is 3 out of 6. Now, I take out the black shirt, so there's 5 shirts. But there's still only 1 red shirt. So that's what this looks like. Now, obviously 3/6 is half, so that's going to give us 1/10. All right, 108. I don't know why they're giving us another cube question. We have 125 cubes. Oh, cool. They're telling us the volume is 125. So it's like the question where they explicitly said the volume is 512. Here they're telling us the volume, but in a kind of a dopey way. They're saying we built it out of little cubes, but that's still the volume. So what's the cube root? Well, it's 5, right? 5 cubed. If I had 125 cubes, I'd have 5 by 5 on the bottom times 5 high. It'd be like a big Rubik's Cube. This is a weird one. I'm going to be very honest. This one was very difficult for a lot of people. This one in 110. All right, so it says that he's taking one box from B and putting it in A. So let's think about the possibilities, right? Let's think about listing out the sample space, and then I'll do the mathematical way, right? So what can happen, right? So he can take 3 and put it in, which means he could take 3 and then choose 3 again. He can take 3 and choose 2, or he can take 3 and then pick 6. Okay, he can also choose 4. He could choose 4 and then choose the 4 again. He can choose 4 and then choose 6. He can choose 4 and then choose 2. He can choose 5. He can choose 5 and then choose 5 again. Choose 5 and then choose the 6, 5 and then choose the 2. So that's my sample space. So I'm going to say, well, how many of these result in me picking an odd number the second time? Just 2 of them. And there's 3, 6, 9 total combinations. So it's going to be 2 9ths. Now, if we're going to do this mathematically, we'd have to kind of case count. We'd say, what's the probability of choosing a 3? Let's do it by choosing an odd number, and then an odd number. And then what's the probability of taking an even number and an odd number? So the probability of taking an odd number, right, I'm going to go back. Initially, the probability of taking an odd number here is going to be 1/3. And once I take that odd number and drop it here, my probability is 1/3. I'm sorry, let me go back. There's 2 odd numbers, so the probability of taking an odd number is 2/3. And whichever one of those odd numbers ends up going in here, my probability of taking it again is 1/3. Sorry about that. So the probability of odd is 2/3. It's the probability I take the 3 and take it again, or the 5 and take it again. Now, what's the probability I take an even number? Well, it's 1/3. Well, if I move the 4 in here, what's the probability of me taking an even number? 0. Right? Probability of me taking an odd number when I move the 4 and there's just a 2, 6, and a 4 is going to be 0. So really, I only have to run this case. So it might be easier, because this is really an unusual question for the SHSAT, easier to list out the sample space like I have, kind of like a tree diagram like that. Okay, think about all the different possible combinations. If we wanted to kind of case count it like I have on the right, probability of odd is 2 9ths, even odd is going to be 0. Okay, 110. So this is an absolute value inequality, right? We don't even see this in Algebra 1. We don't even see this in geometry. I don't think we see this in Algebra 2, until Algebra 2. Now, one thing we can do is we can throw some numbers out there. Right? I'm going to show you guys how the right way to do it, but it's not one we see that commonly. So let's throw some numbers out there, right? So let's check 0, right? Because 0 is only in this one. So if 0 works, we have our answer. So 0 plus 1 is going to be 1. And the absolute value of 1 is 1. That's not greater than 2. All right, so 0 didn't work. All right, so let me try, let's try 2. Because then this one, it would be out, right, if 2 works. 2 plus 1 is 3, which is bigger than 2. Oh, so 2 should be in the solution set. All right, so let me check let's check -2, and let's see if it works. So -2 plus 1 is -1. So the absolute value is 1, which is not bigger than 2. So -2 shouldn't be in there. Okay, that was not bad, right? Now, the right way to do this, we call this a double switch, meaning the absolute value of x plus 1 could be positive. in which case we just get rid of the absolute value symbol. So x plus 1, right? Because if this is positive, x plus 1 would be greater than or equal to 2, which means x is greater than or equal to 1, which is what's here. And then we switch the symbol and the sign on the other side. So x plus 1 is going to be less than or equal to negative 2, right? Sometimes we call this double switch. So I get x is less than or equal to negative 3, and that's this piece of it. And again, we really don't learn that until, it used to be part of algebra before Common Core. Now we don't really get into that until Algebra 2. So that's the way you would do it kind of by the book mathematically. But again, I think they just want you to throw some numbers out there and see what sticks. Okay, 111. This is really just an area question, right? So I have a 12 by 7.5 foot room, right? And I have tiles that are this much on a side. So really I want to take the area. So I'm going to have, so one way to do it is like, okay, that's one of my tiles. I can figure out how many vertical tiles and how many horizontal tiles and multiply. But really what we want to do is take the area. So the area right now is 12 by 7.5. And the area of each tile is 3/4 times 3/4. All right, so we should be able to tell that 7.5 divided by 3/4 here is going to be 10, because there's one decimal place over. 12 divided by 3/4, right? Well, 12 is 48 quarters. So 48 divided by 3 is 16 quarters. 16 times 10 should give us 160. Now, if you wanted to figure out how many of these little tiles, you're going to be doing on this side 7.5 divided by this, which is 10. That's what I did here essentially, right? So there's going to be 10 long, and then I need to figure out how many ways I can go. Same thing, 12 divided by 3/4. I'll do it as a fraction now because it's much easier to multiply by the reciprocal. 12 divided 3 is 4 times 4, which is going to give us 16. And again, 16 times 10 is 160. So that's a tougher one. Again, I would find the area of the whole rectangle divided by the area of each tile. Now, the mistake some of us make is we divide by 75/100 once instead of twice, and then we're going to get something different, obviously. We're going to get, we're going to get something that doesn't work, but that's what I would do. If you want to divide each side individually, that works, or you divide the whole area by the area per tile. All right, so this one should be easy. So we have our weekdays, we have Saturday, we have Sunday. It says there's 3 times as many on Sunday as any weekday. And Saturday is 4 times as many as Sunday. So it says on Saturday and Sunday there's going to be 30,000. All right, that makes this easy. Right, so 30 divided by 15 is 2, so 2,000. And that's how many we'd expect on the Monday. All right, this one is kind of just a computation. 80 meters is the length. It's increased by 15%. So really we want to know 80 times, right, 115%. But honestly, I'm just going to do this in pieces, right? 10% of 80 is 8. That means 5% of 80 is half of that, right, which is going to be 4. So 15% of 80 is going to be 8 plus 4, which is 12. So that's going to give me 92 with my increase. And it says this is 50, which is increased by 10. That's just simple. So now we want to know what percent was the area increased by. All right, so the new area is 92 times 60, and the old area was 80 times 50. And I want to know what percent the numerator is of my denominator. So really, it's kind of like that. All right, but we want to know what the increase is. So I'm going to simplify this as much as possible, right? Clearly, we can divide by 10. I can divide by 4 here. And that's actually going to make things pretty convenient. Because now I'm going to get 20 times 5 is 100. And 6 times 23 is 120 plus 18 is 138. So it's going to be 138 hundredths of what it was before. And if we subtract, that's 38%. Okay, so that to me is going to be the easiest way. So this wasn't exact, I mean, it was a percent of change question, except you'd have to find the area, which is huge, minus the original area, which is 4,000, that's pretty big, subtract that and put it out of x over 100, I think this is going to be a little bit easier. All right, 114. So this is one where I would just use very extreme values. We can do this like kind of algorithmically, if we like conceptually, I guess I should say. But it says they're both negative integers. So I'm going to make x equal to negative 100. And I'm going to make y equal to negative 2. So if I look at answer choice E, negative 100 squared is going to be huge, right? That's 10,000 times negative 2 is negative 20,000. Choice F is going to be negative 400. And G and H are going to be positive because I've got negatives there, right? So those are going to be positive. And obviously we want to square the larger absolute value if I want to push this thing all the way off to the left on the number line. So that's going to be choice E. All right, so I hope you guys learned something new today. I hope this was helpful in our prep for the SHSAT. If you like what you see, I'll have more of these coming up as we get closer to the test. Like, subscribe. You can comment below if you have any questions, comments, concerns, and I'm always happy to answer your questions.